Hey, this is Hellbent, and welcome back to the fourth part in creating a snake-like game. Well, it's not really a game, it's more of an automation uh, thing for AutoHotkey. Um, so let's just jump into it. The first thing we're going to do is we're going to make sure that in the last episode we had, or in the previous episode to that, we had started creating some brushes for each snakes. Now, the way that we have it set up is not very efficient in memory management, but for simplicity for this, it's no problem. So what we have is each snake, when it's created, it gets a brush for its head, which is the color red, and then it gets a color for its body, which is one of other 10 colors, 11 colors, 9 colors. But anyways, what we're going to do now is we're going to make sure that when we close down the program, those brushes get deleted. Now, the way we should actually do these brushes is because we only have 10 or 11 different brushes, what we could do is we could create brushes outside of our snake class, and then each time a new snake is created, we just assign it one of those 10 brushes that we created. But for simplicity, each snake gets its two of its own brushes, but it's not very efficient. So if you want, you can go through and fix that up. So what I'm going to do is in the GUI close, GUI escape, and the hotkey, this is when we close down the program. This is what gets executed. Inside of here, what I'm going to do is I'm going to loop over the number of snakes that we have. Snake.length. So snake.length is the number of snakes that we've created. So if we have one snake, the length is 1. If we have 10 snakes, the length is 10. So we're going to loop that number of times, and then what we're going to do is we're going to delete the brushes. So we have 2 different brushes, so I need to enclose this in brackets or braces, and we're going to delete, we're going to gdip delete brush, and the brush we're going to delete is snake brush 1 and snake brush 2. Snake, this brush 1, this brush 2, yes. So it's going to be snake dot brush, and it's just going to be 1. And we're going to be doing, we need to do this on each individual snake, so it's actually snake index, or the index of the current snake. So if we have 10 snakes, the first snake will be index 1, the second one will be index 2, etc., etc. So we're going to delete brush 1, and then I'm going to copy this and delete brush 2. Okay, so that deals with our management of dealing with our cleanup at the end of the program. The next thing we're going to do is in our creating new snakes, well, I had set up this loop, and what I've decided how to do this is so that way each snake doesn't start with a single segment. What I'm going to do is I'm going to get rid of this loop here, and we're going to actually, because we added in this grow function or this grow method, we don't actually need to worry if we're going to be placing the body segments of a new snake. So when we create a new snake, it occupies a cell within our map array, and our map array is a 2-dimensional array. It's just basically a grid. It has rows and columns. Each one of those rows and columns has one of 3 values. It either has a 1, let me start from 0. It either has a 0, a 1, or a 2. If the cell is completely empty, then it has a 0. If the cell has a wall, it has a 1, and if the cell has a snake, it has a 2. So each cell is divided and it has one of those 3 values. So what we're going to do is when we create our snake, it gets created with a head, and that cell that snake's head occupies gets filled with a 2, representing that there's a snake in that cell. What we can do is if we want the snake to have multiple body segments, or the chance to have multiple body segments when it's created, we can loop over the number of times that we want for it to have a chance of getting a new segment. So I'm going to do 3. So it can get between 0, because we have it set up as a lottery where it's not guaranteed to get a new body segment by passing it into the grow method. just because of the way we have it set up. So we're going to set it up so that way it can get either between 0 new segments or 3 new segments when it's created. And all we're going to do is we're going to take this snake and we're going to call the grow method on it. Yes. So now if I run this, we have it set up so that way we press a hotkey to add our snakes. So if I press number pad 1, it's going to create a new instance of a snake. So if I press number pad 1, we should get a brand new snake, and it should have between just a head or a head with up to 3 body segments. And there we go, we have a snake with 1 body segment. If I do it again, we have a snake with 2 body segments. This one has no body segments. 2, 2, 2, 2, 1, 1, 1, right? Okay, so that's that. Let's go now into the move, so we can get our snake to move around. So in our timer, or in the way that we're actually looping through our game for each frame, we're going to create a new loop, and we're going to also loop through the length of our snakes, but we're going to put this one above our old loop. So right after we fill the background of the screen, we're going to create a loop, and we're going to loop over the number of snakes we have, and we're going to pass each of those snakes into the move snakes or move snake method. Let's see what it's called. Move snakes. So originally when I had wrote this code out, all of the movement and update to the map array and everything like that was dealt with that single method. But since afterwards I decided that I would break it up a little bit so that way it's a little bit more manageable. So the move snake doesn't actually do the movement of the snake, but instead it's a hub that directs different actions from it that actually do the movement. But it's just basically our game loop calls into that, and then depending on what certain values are, what certain states are, it passes it off to other methods that actually do the movement. But as far as our game loop is concerned, the move, this is how it interacts with the movement, or this is how it creates movement. So we're going to loop over the number of snakes that we have, and we're going to pass each snake into the move snakes. Was it move snakes? I think it was move snakes. We're going to pass snake. First we're going to pass the first snake, which is snake A index, or I guess all of them are going to be A index, but A index equals 1 to begin with, and we're going to call move snakes. So we're going to pass each snake into the move snakes method, and then what is this going to do? So like I said, this is going to be a hub that directs everything. So it'll update from here. It's going to send it to update the map. It's going to send it to update the snake's position. It's going to set it to set new directions and reverse directions. But originally all of this stuff was all contained in this single method. So what is the move snakes thing going to do? So the first thing it's going to do is it's going to take our variable that we created called this changer, and it is going to add it's going to add 1 to it each time we pass a snake into it. So if the current snake goes through the loop 10 times, this changer variable will have a value of 10. And then what we're going to do is we're going to let's just set it up. It'll make a little bit more sense if I type it out. So what I'm going to do is I'm going to say if when I add 1, so plus plus, if I add 1 to this snake, because I passed in a particular snake, so if this particular snake has the variable changer is equal to the value that I have set as a random number to begin with, or no, it's not, I have it hard coded, so change at. So if it equals change at, so the first time I pass, a brand new snake will do this, will loop through 30 times before it changes directions. So if it equals this dot change at, then what it's going to do is give the snake a new direction. So this is just a randomizer that says if the snake has been traveling on the same path for a certain amount of time, change directions, give it a little bit of a variety in what it's doing. So I'm going to take this snake and I'm going to pass it to the set new direction method. Okay. Other words, what I'm going to do is I'm going to check. We'll deal with the setting new direction in the later on, probably in the next video. But for now, we're going to deal with actually getting the snakes to move, because there's a lot of code that we have to do. So else if this changer doesn't equal that, we're going to check to see if our snake is stuck. So each time our snake changes directions, what we're going to do is we're going to take the variable this.stuck and we're going to add 1 to it. No, we're just going to check to see if it equals a set amount. We're going to check if it equals a set amount, and we can decide how stuck does a snake have to be before we reverse its direction. So I'm going to say else if this dot stuck is greater than or equal to 15. Then what we're going to do is, so if our snake ends up coiling in on itself, it's going to try to change directions multiple times. Every frame it's going to try to change directions. And each time it tries to change direction, it's going to take this variable stuck and it's going to add 1 to it. After it tries changing directions 15 times, 16 times, it's going to say, you know what, I need to actually change directions. Reverse my direction because I'm stuck. So if the variable stuck, which gets added to each time it changes directions, if it's greater than or equal than 15, we're going to take this snake and we're going to pass it to reverse direction. And we'll deal with the reverse direction after as well. Now that that's done, now we do the main part of the actual moving of the snake. So what we're going to do is we're going to have a bunch of different if statements, and we're going to be just looking at what direction is the snake currently set to go in. So just to recap, if the snake has if its direction is 1, it means up. Or how about this? Up is 1, right is 2, down is 3, left is 4. So if it has a value of 1 in the direction variable, it means that the snake is currently moving up. So I'm going to test to see which direction this particular snake has stored in this direction. If it's 1, we're going to do something. Else if this snake's direction equals 2, we're going to do something else. Else if this snake's direction equals 3, we're going to do something else. Else if this snake's direction equals 4, we're going to do something else, and that's it. So we have 4 directions, so that's the only way it can go. So if the direction is 1, what are we going to do? Well, what we're going to do here is we're just going to check to see if the cell in front of it, so let me pull up my drawing. Which key do I need? Okay. So let me do a horrible, let me restart that. Okay, so we have a snake and it's occupying different cells, and each of those cells gets a value of 2. But for the simplicity, I'm just going to squiggle it out. This is a snake. Let's say this is our snake's head, and it has a value, it's set to be going in a direction of 1, which means it's supposed to be moving up. What it's going to do is it's going to look into this cell to see what value it has. It either has a 0, a 1, or a 2. In order for our snake to move into this cell, it needs to have a 0. So that's what we're going to look at. We're going to look, does this cell have a value of 0? If it does, we can go ahead and move into it. If it doesn't, we need to change directions. So we're going to look at the map. So we've created a map, a grid that holds all those values. So we're going to look at, we're going to say, we're going to put a ternary statement. We're going to say map. We're going to look at the snake's head. It's only its head that we need to look at, so we're going to look at the snake's head, the X and the Y for the head. So I'm going to say this dot snake array, which is an array that keeps track of all the segments of the snake. So each segment has an X and a Y. So the head has an X and a Y. The next segment has an X and a Y. The next segment, and so on. So snake array, and we're going to be we only care about its head. So we know that the head is always the first index in the snake array. So we just type in 1, and we're looking at the Y, because we're setting it into our map array, which is set to be y, x, y, x. So is the head of the snake's y minus 1, because we're going to be moving up. So in our grid, let me in our grid, I'm not actually going to draw the grid. If we're moving up, our y is getting smaller. If we're moving to the right, it's our x is getting bigger. If we're moving down, y is getting bigger. And if we're moving to the left, x is getting smaller. So we're going to look at if the cell above this current cell snake, so it's -1 because we're moving up. And then we're going to look at the x, the snake's x. And we're looking at the head, so it's index 1 dot x. If this equals 0, and now this is a question, so is the cell that is currently above the snake's head, is it empty? Question mark. If it is, then what we're going to do is we're going to pass our snake to update snake's position. So we're going to take this snake, and we're going to call the update snake's position method on it. Other words, obviously if it isn't a 0, then there's only one other option. It must be a 1 or a 2. So in that case, what we need to do, if it's not a 0, we need to change direction. So what we're going to do is, if it's not a 0, we're going to, instead of taking our snake and passing it to the update snake's position, which actually does the moving, we're going to take our snake and we're going to pass it to set new direction, because it needs to change directions. This dot, we're going to pass it to set new direction method. Set new direction. And once again, if our snake keeps going through this over and over again, eventually it's going, each time it changes direction, it's going to add to our stuck variable, and sooner or later our stuck variable will get greater than 15. Okay, so that's that one. For the simplicity, what we can do is, because most of the code for the next couple of if statements is going to be the same, I'm just going to take this same statement and I'm going to put it into here, just paste it into here and change it. So this time if we're moving to the right, so we're not going to be looking to see if we're not looking in the cell that is above us, we're looking at the cell that's to the right of us, or to the right of the snake's head. So we're going to take this, get rid of that, and instead we're going to be looking at this snake's first array x position +1. Does that one equal 0? If it does, go ahead and pass the snake onto the update snake's position. If it's not, change directions. Else if the map array, This time we're going to be moving, direction 3 is moving down, so Y, we're not looking in the cell above us, we're going to be looking in the cell below us, which is +1. If that equals 0, go ahead, pass the snake to the update snake position. If not, pass the snake to set new direction. And last, if direction is 4, we're not going to be looking in the cell above us. We're going to be looking in the cell to the left of us, which is x minus 1. If it is 0, go ahead, pass the snake to the update position. If not, set a new direction. Okay, so let's go into the update snake's position. So in here, if our snake is actually able to move, what we're going to do is we're going to take that variable this stuck, and we're going to say, well, if the snake moved, obviously it's not stuck, so we're going to reset it back to being 0. So if it was stuck for 7 turns in a row, but then all of a sudden it got the opportunity to move, we're going to reset stuck back to being 0, because it's not stuck anymore. The next thing I'm going to do is, before we actually move our snake, what we're going to do is we're going to update the map, because right now the location where the snake currently is right now the location that the snake currently is has a bunch of 2's. So this is our snake. Our snake is like winding across our screen like this, and here's the snake's head. Before we move our snake to its new location, what we're going to do is we're going to take all these spots that the snake is in our map, and we're going to 0 them out. So that way, when after it moves, if another snake wants to come, it can. So we're going to 0 out all those 2's, and then when our snake moves to its new position, we're going to look at where our snake is, and we're going to replace those with 2's again. So this last spot here will end up being a 0, but these ones will all be 2's, and our new head will be a 2. So we're going to pass, first we're going to pass our snake to the update map array, so that way we can 0 out all the values. And we're going to pass it an argument, so that way we only have to do this for one thing. So we're going to pass it an argument of what value are we going to be changing where the snake is, what value are we going to be changing those grid spaces to be. So because we're going to be zeroing it out, we're going to pass a 0. And then up in here, we're going to call that new value. So the new value is going to be a 0, and then all we have to do is we have to loop over the number of segments of our snake. So if our snake has 10 body segments, we're going to loop 10 times and replace each one of those with a 0. So we're going to loop. The amount of times we're going to loop is however long our snake's body is. So this snake array dot length. So if our snake has 10 body segments, it's going to loop 10 times and go through each of the snake's body segments. So what are we going to be updating? We're going to be updating the map. We're going to be updating the map, and the values are going to be the X and the Y for each of the snake's body segments, which is because we're looping, it's going to be the index. So to begin with, it'll be the first segment, then the second segment, third segment, all the way through all of the snakes. So we're going to say this is going to be for the Y position for each of the segments. This dot snake array a index dot Y, and also this dot snake array a index dot X, and we're going to change that to whatever it was before. We don't care. We're going to change it to a 0 now, because our snake has it's already proven that the space in front of it or beside it or whatever direction it's going, it's already shown that yes, that space is empty, so it is going to be moving. So we can safely change all the values of its current location to 0, and then we can move our snake, and then we can do this, call this update map again, and replace them with 2s instead. So let's go through actually updating our snake. To do this, what we're going to need to do is let's not look, this time we're not going to be looking at the map. This time we're going to actually look at what our snake's array looks like. Our snake's array looks very much like our map array. It's just a bunch of different cells. And each of the cells contain a value for a X and a Y. It also has a position that it's in our array. So let's say that this is our head. This is going to be position 1. This is position 2. This is position 3, 4, 5. So each of these positions has an X and a Y. And what we're going to do is, in order to move our snake, so our snake, let's say it's going to be moving this direction, in order for us to have its tail follow it, what I'm going to do is I'm going to take its last position, and I'm going to say that it equals whatever was in this one. So this cell had a X and a Y value, so I'm going to say that the last body segment now equals what it equaled. And what does this segment equal? Well, this segment equals whatever this one equaled. And this one equals whatever this one equaled. And this one equals whatever this one equaled. So that way, even if our snake is twisting and turning all around, it's just going to copy, each cell is going to copy, or each element in our array is going to copy the one in front of it. And the first body segment, what it's going to do is it's going to look at what direction is it supposed to be moving in, and it's going to use that whatever direction is as its updated value. So all of its tail segments are going to copy the cell in front of it, and the head is going to copy the cell of whatever direction it's moving into. So to do that, we need to loop through. All the other times we've been looping through our snake array forwards, or going like from its head all the way down to the bottom of its tail. This time we need to reverse that and start with the last segment of its tail and work towards its head, because otherwise we're going to be overriding values and they're not going to work out quite so well. So I'm going to create a variable that I'm going to call I, and I'm going to set it to equal the length of our snake. So if our snake had 10 body segments, it's going to equal 10, etc., etc. So the I, we're going to go through each of the segments and update their position to be the one that's in front of it, and then we're going to subtract from I. So I starts with the last body segment, and then it's going to do its update, and then I is going to get subtracted, so that I is now the next segment of our snake. So to do that, we need to loop over the number of segments of our snake. This dot snake array dot length. So we're going to loop. If our snake is 10 segments, we're going to loop 10 times. What we're going to do is we're going to test to see if For efficiency, what we're going to do is we're going to check to see if I does not equal 1. If I does not equal 1, we're going to do this bit of code first, because the I is only going to equal 1 once. So if we have I equaling 1 being our first test, every single time we go through our body segments, we're also going to have to test. Does it equal 1? No. Okay, let's do this thing. Instead, what we're going to do is we're going to say if I does not equal 1, which is going to be true more often than not, we can go into our first if statement. So if I does not equal 1, then what we're going to do is we're going to take, I think I need to, I need to update its x and its y. So what I'm going to do is I'm going to take this dot snake array, and the position that we're going to be looking at is the current value for I. So to begin with, it's the very end of the tail. That dot y is going to now equal whatever the segment in front of it was. And that segment in front of it is I minus 1. So if I equals 10, this segment is 10, it's going to change it with I minus 1, which is 9. So 10 becomes 9. And we do the same with the x. Okay, so that deals with all of our body segments. So if I equals 10, now it equals 9. And then if I equals 9, now it equals 8. And so on and so forth. So this is dealing with all the body segments. Now we need to deal with the 10, the head. So in this case, we were checking if I didn't equal 1. So if it didn't equal 1, deals with everything except for when I equals 1. So all we have to do is say else. Because obviously now if we're in this else statement, I does equal 1. So that's our head. And in here, we're going to test a couple of things. We're going to test what direction we're going, because that's going to determine what way we're going to be looking. So I'm going to say if, I'm going to put this into a ternary statement so I can do it all in one line basically, but I'll break it up into lines. I'm going to say, is this dot direction equal 1? That's a question. If the answer is yes, then what we're going to do is we're going to take this dot snake array, we're going to be looking at I. I could put 1 here, or I could put I, because I equals 1, so I could do either. Y I was thinking, do I need to move both X and Y? But no, I don't. Because it's the head, and it's not going to be it's not following anything else. It only needs to update the thing that's actually changing. So if it's moving up, it only needs to change the Y, because the X is still going to be the same. So let's say this is the head of our snake, right? It has an X and a Y. X equals, let's say, 1. Y equals 2. If we're moving up, the cell above it still has the same X value, but the Y value is going to be different. In this case up here, it's going to be Y is 1. Right? So all I need to do is change, depending on the direction, I only need to change one of the X or the Y, because if it's moving up, this is still cell X1. But it's Y1. This is X1, Y2, X1, Y1. So we're going to subtract 1. So this dot snake array, the first position equals Y, what it was, minus 1. Um, it's not -1. I'm not going to be moving to the cell -1. I'm going to be subtracting 1 from its current position. Okay, that's it for that. Now what we're going to do is we're going to say else if that wasn't true, so if the direction wasn't 1, then maybe the direction is 2. That's a question. Is the direction 2? If it is, take this snake array, index I, which is its head, dot x, because we're moving to the right this time. So what are we going to do? So this time we're moving to the right, so x is getting bigger. So we're going to take x and we're going to plus equals 1. Okay, if that wasn't true, maybe the snake is going in direction 3. If it is, then go ahead and take the snake array, index I, or the head of the snake, and we're going to be moving down, so we're going to be using y, and we're going to be, because down is greater numbers for the value, we're going to plus equals 1. And last, we have one more thing to test, which is, actually, I guess we don't, because it's the only thing that's left, it only has 4 directions it can go, we don't actually need to ask a question, is the direction 4? Because obviously, if it's gotten through, it's not direction 1, it's not direction 2, it's not direction 3, the only thing left is that it must be direction 4, so we don't need to ask the question, is the direction 4? Well, I think that's given. So we're not going to ask a question this time, we're just going to automatically set this dot. And we're moving to the left, so x is getting smaller, and that's it. I need to put this actually into that. Okay, so this happens if our snake is 10 lengths long, it's going to loop through this 10 times. Each time it loops through it, we're going to take the value of I now, and we're going to subtract 1 from it. And then the next thing we're going to do is after it's updated our snake's array, what we're going to do is we're going to update the map with the new positions of our snake. So we're going to pass, so just once again, we're going to pass our snake into the update map array. Let me clean that up a bit. So we're going to take this snake, we're going to pass it to the update map array, except this time its value is going to be 2. Because our snake has moved, so now we're going to set the value, the position in the map, saying that this is where the snake is. And we have that already set up, so we're good. So like I said, we'll worry about these ones on the next one because we're probably getting pretty long. Yeah, we're up to 40 minutes almost. So let's go ahead and look at what we have. So now we'll have a bunch of snakes that can move, but as soon as they encounter something, they're going to call the set new direction, but that doesn't have any code in it yet. So snakes will keep moving until they encounter a wall or another snake. So we'll start with one snake, and it's not moving. Why isn't it moving? Did I put this into here? Snake A index, move snakes, yes. So what we're going to do, I guess we have to do a little bit of debugging. So let's go into the snakes function, and we're going to put up a tooltip saying that we are here. Okay, so we are getting into the move function. Next, let's go into the update snake. We're not getting past to the update snake, so I might have some typo. So I'm going to copy this. Let's see. Yes, it was. So it's snakes. I always do this kind of thing. So we're passing it to update snake's position. I think we should be good. So I can get rid of that tooltip. Let me just comment it out. And we still have an issue. So did I not? Do I still have typos? Update this snakes. Okay, no, that looks right. Alright, so I guess we have to do more debugging. So let me grab, so we're in here. So we are in here, and we probably have something wrong. So let me run this again to see if we were getting any movement. I thought I saw some movement, yeah. So down is working, up is working, left and, okay. Huh. I'm not really sure what's going on. I have to look. Snake array length. Oh, you know what? Okay, I see what's going on. I do see what's going on. I have it here as new value, and this should be, I'm passing it each time it's doing it, it's updating it as a 0, so I need to actually update it as a new value. I don't know if that's the cause, but that's definitely a problem. So when we're moving our snake, we first 0 it out and then we put it to 2 afterwards. I don't think that's the problem, but maybe it is. No, it's not the problem. So we have an issue. Something's wrong here. Like, the thing is, it's impossible that... Oh my goodness. I'm an idiot. It's doing exactly what it's supposed to be doing. Okay, let me paint the picture to you. Okay, I think I see what's exactly going on. Okay, so we have our grid. And then we have a snake that is randomly painted into it. Alright, I'm going to make this its head. So this is its head. Okay, each time a snake is created, it's given a position where it starts, a length, and everything like that, but it's also given a random direction. Well, what if the first direction it's given is back on its body? Well, that value isn't going to be a 0, so the snake isn't going to move. So that's why a snake, when it forms in, if its direction is back on its body, then it's not going to move. It goes into the set new direction, which currently doesn't exist. So that's why our snake, when we pop it in, And I don't know why I didn't think of that. If it doesn't move, it means that it's in this snake, this is its head, so its direction was up, but up is into its own body, so it can't go that direction. This one is also up. This one is down. That one's to the left or right. That one I don't know because it's only a head. That one's down. That one's to the left, right, and so on and so forth. So if the snake ends up getting us a random direction that's into its own body, then it would have to call the set new direction, and that doesn't exist. Well, anyways, we'll continue on and we'll finish off everything in the next video. I hope you enjoyed. Peace.